earlier. Okay, so we're going over the 2-1 homework. I'm gonna come get your ISEP sheet if you still have that. If you just sit on school, that's fine. So I think it's the reason that's not great is that it could get harder than it's also be correct. So in this case, the common thing, I guess there wasn't really a common thing on that one. It was just multiple to 5, and so you could think of it as like adding 5 each time, but then alternating. So I guess that's not as bad as I thought it was. That's a fine enough answer. This is just kind of crappy sequencing. Any other questions on 1 through 6? All right, you want me to move on? As we move on, 7 through 10, as I told you in our lesson, that you need to write like a sentence or a math sentence about this, and that if you left it blank, it'd be unacceptable, and none of you did, which is awesome. So you maybe don't have what I have. That doesn't mean you're wrong. We can talk about if you were like, this is what I wrote as a conjecture. Remember, it can be true or it can be false. So you could write something that's not necessarily true, but it was a guess you made based on that information. So you want to check yours, let me know. If not, those are the ones that I thought were the most obvious based on the information given to us. You could have done that for number 1. So Allie asked if we could do segment addition on the first one, NP plus PQ equals NQ. Yep, for sure. Oh, Jeanette, I found it. I don't know what happened. Put that with Allie's paper and I'll deal with this later. All right. Anyone 7 through 10 I need to talk about? Can we leave it there for a minute or are we ready to move on? Griffin? Yeah. Anything else? All right, I'm gonna keep rolling on this. I'm gonna go to the next page and I'm gonna try and look at just those first 3. Now, you don't have to necessarily have everything drawn or written like I do, but you need to understand like kind of why I am doing what I'm doing. So the first one, it says, if ABC and CBD form a linear pair, then angle ABC must be congruent to CBD. I said that was false, and then I drew an example of a linear pair where the angles were not congruent to each other. You didn't necessarily have to write ABC could be 120 and CBD could be 160. Those are examples, but you don't necessarily have to have that. You could just draw a picture and call that a day. Number 12 said if A, B, B, C, and A, C are congruent, then A, B, and C are collinear. That one's just false. If you look at the two pictures I drew, the first one I tried to draw them in a line. I was like, okay, well, let's put A, B, and C all on a line. A, B, and B, C I could make congruent, but if they're congruent, then AC can't be the same as them. AC is if you add up A, B, and B, C, so there's no way for it to all be the same. Another thing you can't do, but everyone feels sometimes tempted to, is sometimes people think, oh, well, I'll just put another C over here and it'll be CA this way. You can't have two C's in the same picture. Like, you just can't do that. It can only be one point with that name. Another example I drew is if AB, BC, and AC were all congruent, but I couldn't get them in a line, they were all non-collinear. So it looks more like an equilateral triangle than all in a statement. So there's a couple different ways you can think about it. Any questions on 11 or 12? Okay, what about 13? If AB plus BC equals AC, then AB equals BC. That one I said was false, and I just drew a picture. I said, look, AB could be 2 and BC could be 10. They still add up to AC, which is 12, but they're not equal to each other. I just did an example. I'm going to move a little bit so you can still see 12 and 13, but we're going to add in 14. 14 says if 1 is complementary to 2 and 1 is complementary to 3, then 2 and 3 are congruent. I drew a picture to show that was true. Basically, if angle 1, I picked it was 75. It can be whatever you want. I said, okay, let's say angle 1 is 75. Well, if angle 2 is complementary to it, then 1 and 2 have to add to be 90, which makes 2 15. And if 1 and 3 are also complementary, then that means they need to add to be 90. So the only thing that adds with 75 to be 90 is 15. Mm-hmm. You can write it in words, you can do a different explanation, you can draw it a different way. I'm just showing you this is what my brain was processing. This is what I was thinking. You need to give me a counterexample though. Unless, actually, wait, this one's true. You don't need to give me a counterexample. Good question, Griffin. If it's true, you can just say true and move on. I think I showed you because sometimes we don't understand why it's true. Okay. 15. I'm gonna keep going so we can see all of them at the end now. So we just talked about 14. We can see 15, 16, and 17. 15 and 17 were true, and I just drew a picture to show you that they were true. So if you had false, I'm just showing you why that makes sense. And again, you don't necessarily need a picture or words if it's true. But 16 was false, so you do need a picture or words on 16. If angles 1 and 2 are adjacent, then angles 1 and 2 form a linear pair. Well, that could be true. I drew an example of that being true in pink, but it could also be false, and I drew that example in purple. Just because they're adjacent means that they share a side and a vertex and they don't have any overlapping points. There's nothing that says that they have to add up to 180. So I drew like an acute angle that like had 2 angles in it, 2 adjacent angles. Any questions? Give me some thumbs. Are we doing okay? Are we doing in the middle? Are we doing like 4? Okay, I see some middle. I see some good ones. Good. Yep. Others go. Can I move past 17, guys? There we go. Right at the top now. Okay. I'm okay if we're in the middle. Conjectures take a little bit of time and counterexamples take a little bit of time. So if that's something we need to work on, that's okay. And then if we're good, awesome. Alex? Can I go to 11? Yes. Give me 1 second. Can I move past 16 and 15? Anybody object? Does that work? Okay. As you finish making your corrections, make sure you turn it in. I believe it's homework 12, 2.1. Make sure it's uploaded on Schoology. You guys as a class have done the best job of turning in homework, but if there's anything missing, make sure that you either talk to me about it or look to see if you have it or do it if you never did it. So Let's get those kind of figured out. Go back to 17. Alex, can I move from 11? You sure? Okay. Oh, the one thing I didn't talk about in 17 is that upside down T. I mentioned that on Monday, and it was on your study guide for the last test. The upside down T is perpendicular. So if you see this sign, it means perpendicular, and that's just what happened. So when those two lines formed a right angle at their intersection, that means that they are perpendicular. Okay. While you finish that, I'm going to come around and give anybody who wants some paper notes, and then we're going to get into section 2.2. So again, if you haven't turned in your papers, turn those in. If you want to do your notes online, 2.2 is online, so go ahead and check that out. And if you want a paper copy, here it comes. Right? 2-2. Today is Wednesday, which is a lesson. Everyone get a paper who wants one? We're doing some writing today. It's going to be a little English classy today. You know, like word favorite. My stylus really quick. My writing's not too messy. All right. Everybody with me? Okay, we're talking about conditional statements today. So conditional statements are any statements that have an if and a then. So if it's an if-then statement, it is called a conditional statement. The notation we use, so a lot of geometry is just funny or different notation. The notation we use is this P arrow Q. That means if P, then Q, or P implies Q. I don't often say that. That doesn't really stick in my head, but I'll say if P, then Q. Or sometimes I just say P, then Q, and like assuming we know if goes there in front. So if I say P, then Q, that's what that means. This little P arrow Q. It's just my notation. When we have a conditional statement, there are two parts. There's a hypothesis and there's a conclusion. The hypothesis goes after my if. It does not include if, it just goes after if. And then my conclusion goes after then. Okay, so conditional statements have a hypothesis and conclusion. So an example I have is, if you do your homework, then you will pass geometry. My hypothesis is everything that follows the if. So you do your homework is my hypothesis. So I can label it as hypothesis or P. If you're doing pencil paper, you can highlight with a highlighter, or you can underline or something to show that it's different. And then my conclusion is everything that comes after then. So you will pass geometry. That's my Q. Notice I didn't highlight if, notice I didn't highlight then. Same idea for the next one. If you skip breakfast, then you'll be hungry before lunch. What's my hypothesis? Good, you skip breakfast. It's my P. And then what's my conclusion? You will be hungry before lunch. Very good. Cute. So conditional statements could be written in if-then form, so it's really easy to see hypothesis and conclusion. Sometimes it's not written in if-then form, so we need to write it in if-then form. So we're going to write the next three sentences as if-then sentences and identify the hypothesis and the conclusion, okay? So the first one says, geometry teachers are cool. Now, we're not adding anything too extra to this. So basically, your sentence is going to say if something, then something, and you're really only using geometry teachers are cool. I'm going to preface, this doesn't mean it's a true statement. Conditional statements can be false. How would I write this as an if-then statement? If what, then what? Maddie?
If teachers are cool, then no wait. If no, I don't know.
Allie?
If you're a geometry teacher, then you're cool.
Then you're cool. Good. And Maddie, I like that you tried, but I like that you also knew cool shouldn't go first. So if you are a geometry teacher, or if someone teaches geometry, or if a teacher teaches geometry, anything along that line, if you are a geometry teacher, then you are cool. What's my hypothesis of that sentence? What's the hypothesis? Who can help me?
If you are a geometry teacher.
Good. Lose the if though. Just you are a geometry teacher. And then what's my conclusion? You are cool. Very good. Awesome. Next statement. I will dry the dishes if you wash them. How do I write that as an if-then statement? Good. If you wash the dishes, then I will dry them. Good, Gavin. And again, we got to identify my hypothesis and conclusion. What's my hypothesis? You wash the dishes. What's my conclusion? I will dry them. Very good. And then the last one that we're going to write is if then. It says a number divisible by 9 is also divisible by 3. You can write that. Griffin?
The number is divisible by 9, it's also divisible by 3.
Very good. If a number is divisible by 9, then it is also divisible by 3. So let's do hypothesis and conclusion. Who's someone I haven't talked to yet today? What's my hypothesis? Sterling? Perfect. Number divisible by 9. What's my conclusion? Anybody? Maggie?
It's also divisible by 3.
It is also divisible by 3. Awesome. Good job, guys. Not too bad, right? All right. So conditional statements, I already said, can be true or false. A true conditional statement means that there's no counter examples. It's usually something that's like the definition, or it's like a theorem or a postulate or something. And so that means if the hypothesis is true, then my conclusion is also true. So I've got two examples of true conditional statements. The first one is if measure of angle D is 110 degrees, then angle D is obtuse. Could the measure of angle D be 110 and the angle not be obtuse? No, right? That's like what the definition of obtuse means, right? Obtuse means it's bigger than 90 and it's less than 180. This has to fall in that category. So kind of by definition, that's true. The other example is if two angles are supplementary, then their measures sum to 180. Could two angles be supplementary and their angles not add to 180? No, right? That's the definition of being supplementary. So true statements are a little bit harder to come by because they have to be true like all the time. It's a rule, it's a definition, it's a theorem. Statements can be false if there's at least one example where the hypothesis is true, but the conclusion is false. So that's when we have a counterexample. So if we can come up with a counterexample, then we can prove that the statement is false. So for example, number 1 says, if I live in Indiana, then I live in Indianapolis. Is it true that I could live in Indiana and not live in Indianapolis? Where could I live? Carmel? Where else could I live? Fishers? Where else could I live? Fort Wayne, yeah. It doesn't even have to be in central Indiana. It can be like way north or way south. There's a ton of places, right? I bet a lot of us don't even live in Indianapolis, right? Does anyone truly live in Indianapolis or Marion County? I know I do. A lot of us do, but a lot of us don't, right? A lot of us live in suburbs or a city outside. All right, and then if angle P is acute, then measure of angle P is 25 degrees. Could angle P be acute and not 25 degrees? Yeah, what could it be? 30. What else could it be? 89. What else could it be? 42. What are my restrictions here? Like, what are we picking numbers between? Lower than 90. Good. 0 to 90. So anything between 0 and 90 would be fine. And we could play this game all day, right? We could list acute angles all day. So those are two examples where the first part was true, the hypothesis was true, but the conclusion we could find a counterexample. All right. Okay, next we're talking about something called the negation of a statement. The negation, N-E-G-A-T-I-O-N. Negation means that I'm putting not into my statement. I'm negating my statement. It's like when if you have like a little brother or sister or like a cousin who's like 2 or something like that, and they always say like no, or like I am not. Do you recognize that when like little kids say like no all the time, or like you're like, oh, you're getting so big, and they're like, I am not, and you're like, okay, cool. That's what a negation is. A negation is like your 2-year-old cousin or something like that that's putting not in stuff. If I have a statement, I am short, I'm not going to negate it by making a new statement. I'm not going to say, oh, I'm tall. That's the negation. No, the negation is I am not short. We are not changing any of the like meaning of this statement. We're just putting not in. So the negation of I am short is I am not short. Not I am tall. I am not short. My notation for this is this little curly in front of my P. So it's just P, just the hypothesis. It's like if we had like our congruent mark, but got rid of like the equal signs underneath it. That's the same curly that I make, a little tilde like in Spanish, or a little, and I read that as not P. So if I say not P, this is what I'm like thinking in my head. Okay, you doing okay so far? Thumbs up, signs of life. Good, okay. All right, now we're gonna learn about a couple different types of conditional statements. So I have a statement, it says vertical angles are congruent. Before I teach you about other types, let's make that an if-then statement. So how do I write vertical angles are congruent as an if-then statement? If what, then what? Sarah? Very good. If they're vertical angles, or if 2 angles are vertical, or if you have 2 vertical angles, anything like that, then they are congruent. If they are vertical angles, then they are congruent. Okay. And what's my hypothesis in this example? Good. 2 angles are vertical. They are vertical. And then what's my conclusion? They are congruent. Good. Okay. Good. Okay. Now I want you to put your pen or pencil down, and I want you to look at me with 2 thumbs up. This is a normal conditional statement. If P, then Q. My P is normal. My Q is normal. Okay. We're going to do converse, inverse, and contrapositive, and they are going to change our thumbs, and that's going to help us remember what's going on. So the first one is converse. The converse is where we switch our P and our Q. So now it goes, if Q, then P. Okay? So I'm going to rewrite my sentence and put my conclusion first, and then my hypothesis second. Cool? I'm going to write, if they are congruent, then they are vertical angles. All right, go do that. If they are congruent, then they are vertical angles. I'm going to keep my highlighting trend going so you can see that I physically switched my conclusion and my hypothesis. My notation for that is if my normal thing is P then Q, my switch is Q then P. So I'm going to write that next to notation. I'm going to write Q arrow P. Okay. All right, once you do that, pencils down, thumbs up again. We always reset at conditional statements. So converse is where we switch them. This is my normal conditional. Now I'm doing inverse. Inverse is you negate them. So we go thumbs down, which means not. It's in the same order though. It's in the hypothesis goes first and the conclusion goes second, but they're both not. All right, go write it. If they are not vertical angles, or if two angles are not vertical, then they are not congruent. I'm going to highlight again. I have not with my hypothesis. I have not with my conclusion, but they're in the same order. And since they were in the same order, but just negative, I'm going to write not P, arrow, not Q. I'm going to write curly P, arrow, curly Q. Not P, not Q. Okay, when you're done with that, put your pencil down, give me thumbs up. Okay, so we did converse, which is where we switched them. We did inverse where they were negative. And now we're doing something called contrapositive where we switch and negate them. I don't care if you negate them and then switch them, or if you switch them and then negate them. At the end of the day, we're going cross-arm thumbs down. So that means I'm switching them so the hypothesis is second and the conclusion is first, and both have nots. So not Q, not P. Go write it. Switch and negate, switch and negate. If they are not congruent, then they are not vertical angles. I'm going to keep my highlighting going, not conclusion at the beginning, not hypothesis at the end. And this notation was not Q, arrow, not P. All right, we're going to refer back to this. Any questions so far? I taught you the hands because we're going to practice this later on, because if I get to a test and I say write the converse of something, I want you to physically think, okay, converse is this. When we took the test last year, kids would sit there and be like, okay, this is converse, this is inverse. They were like doing this at their desk, like by themselves, trying to like figure it out. And that's the best way I think of to remember these things. So, okay, flip your paper over. We're doing another example, but now we're talking about the truth value of these. So I have conditional first. That's my normal P then Q. If two angles are adjacent, then they have a common side. Is that true or false? If two angles are adjacent, then they have a common side. I think that's true, right? If they're adjacent, that means that they have a common side. That's an example of adjacent angles. So yeah, that's true. I believe that. I'm going to write true next to that. True. We're going to write the contrapositive, the converse, and the inverse of that statement and decide whether they are true or false. Okay? Contrapositive. Do you remember what the hand sign that is? Good, Allie. Upside down and flip. Very good. Write that for me if you haven't already. If they do not have a common side. You can also abbreviate to they don't. You don't have to write not crazy. Sometimes I'm dramatic about it. You don't have to be. But sometimes that helps me know that I did put it in there. If they don't have a common side, then two angles are not adjacent. I like to be consistent, so I'm going to be consistent. All right, let's read this. If they don't have a common side, then two angles are not adjacent. Could we have two angles that don't have a common side but are adjacent? No, right? That's part of the definition. So I'm going to write this one is true. We don't have to give a counterexample because that's true. That's just the definition. Conditional and contrapositive are both true. That's interesting. Let's see if there's a pattern we can find. Hint, hint, there will be. All right, let's do the converse. Does anyone remember what the sign for the converse is? Good, Jaden, I see you. Switch them. So it's just conclusion goes first. If they have a common side, then they are adjacent. And two angles are adjacent. Okay, so now we have to ask ourselves, could we have angles that have a common side but are not adjacent? I think yes. Do you remember on those notes 1-5 that I gave you a bunch of angles and I showed you that they weren't adjacent? There was one that I drew kind of like this, where I had like an angle here and then an angle coming off of it. Do you remember why those two weren't adjacent? They don't share a vertex, but they did have this common side. So this is an example of where they have a common side, but they are not adjacent. So I'm going to write false here. That is not true. If they have a common side, they could not be adjacent. Okay, so that's a different truth value than conditional and contrapositive. Interesting. All right, and then the last one we're doing is inverse. What does inverse look like? Good, 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 good. Down, down, down. Same order, negative, negate them. So if, and I'll zoom out in a second, if two angles are not adjacent, then they do not share a common side. Promise, I'm trying to write not the worst, but this is really bad today. You don't want to write it off? I can't write it off. Okay, I gotta get out of notability. Give me a second. Well, I'm getting my notability fixed. Could we have two angles that are not adjacent but do share a side? Coach Vogel's trying to play our game. Yes, right? That's the exact same example I just gave last time. Those were two angles that weren't adjacent, but they did share a common side, right? So that makes my inverse false. So that means that my converse and my inverse, they have the same truth value. They're either both true or both false. What that means is that my conditional and my contrapositive are logically equivalent because they're both true. And my converse and my inverse are logically equivalent or logically the same because they're both false. So any two statements that are both true or both false are logically the same. And that is helpful to us because sometimes based on how they're written, like the inverse might be really like much easier to understand whether it's true or false than the converse is. Sometimes when you throw all the knots in, it gets really confusing, or sometimes when you mix all these things up, it gets like a little confusing. You're like, wait a second, what? So if I can know that like the conditional statement is true, then I know that the contrapositive statement has to be true. So vice versa, if I know like the inverse is false, then that means that the converse is also false. Okay, we're gonna do some stuff with what we call truth tables tomorrow. So I wanted to introduce this idea of being true or false. What I'm gonna do, we still have a few more minutes left of class, and I want you to practice this part right here, either by yourself or with a friend, and then I'm gonna come back and we're gonna talk about it together. I'll need some friends to help me, so you decide if you wanna help me. And while I do that, I'm gonna pass out your homework if anyone wants a paper copy, okay? What's the gift after that? Let's go back. Let's put it down. When they're nice. So nice is the end of the sentence. Nice is at the end of the sentence. So nice will be my dad. The if part is if you are a teacher, or if he is a teacher, or if it was a teacher. Does that make sense? A lot of times I do that, give you a very small amount of words to say right if then. You don't want to make anything else up. But it kind of follows the sentence structure. If it starts with all teachers are nice, then we're going to end with nice and start with teachers. So I wrote, if you are a teacher, then you are nice. You could write, if they are a teacher, then they are nice. You can write, if he is a teacher, then he is nice. If a person is a teacher, then that person is nice, whatever you want to write. Okay, so that's my normal one. Who wants to help me do the inverse? Or do we need a minute? Allie, you want to help me with the inverse?
If someone's not a teacher, they're not nice.
Good, negate, negate. If someone is not a teacher, then they are not nice. Now you want to do converse?
If you are nice, then you are a teacher.
Good, switch them. If you are nice, then you are a teacher. All right, and who wants to do contrapositive for me? Maddie?
If they are not nice, then they are not.
Good. If they're not nice, then they are not teachers. Switch and negate. And I'm going to go back and highlight all my steps so you can kind of see how it follows, whether we are negating or switching. Yeah. Your 2-2 homework, I know it looks long, I'm gonna preface that, but a lot of it's writing. So it's just writing sentences like that, so I had to give you space to do that, okay? So make sure that you put aside plenty of time to get that done, because I do see you tomorrow, correct? Yep, tomorrow we have lunch together. So you've got a lot of good examples on this page. You can spend a little bit of time. I don't remember when the bell rings. It's either in a minute or 6 minutes, so you can work on this if you want. Yeah, and then that's class. Good job, guys. I'm going to stop the recording so